Zoom setting up the live stream now. Okie dokie, let's get started. Welcome to January 14th wasmCloud community call. Today we're going to be giving an update on our continued wasmCloud v2 development. We've got a nice beautified little demo actually to show with that. Has a UI and everything. Lucas is going to walk through that, and we've got a couple docs of the week that we've added. I think we'll go through this pretty quick, so if other folks have things they want to chat about, just go ahead and maybe queue that up in the Zoom chat here. With that, Lucas, you want to kick us off on where we are with a wasmCloud v2 update?
All right, let me share my screen here. So V2 is going fine. We have plenty of new stuff being merged, and we also have some key core changes to how wash dev and wash build work. And today I want to show two things here. The bulk of these changes that I'm talking about, which they do significantly change how wash dev is positioned as a local development tool, and also show a bit of the giving one of our demos a bit of a facelift, so it kind of is a bit more presentable. And I'll start with the demo because then it's gonna be used as an introduction to the remaining changes. So here I'm on the wash repo, and what I'm gonna do is gonna do cargo run, which is essentially running wash dash c examples blobby dev. And this is analogous to doing, probably better to just type here this. So I have blobby example here under this directory, and what I'm telling wash to do is the -c is use that project directory. So before wash does anything, one of the new things going on here is it will switch the local directory, the local process directory, to the project directory. And from that point on, all paths that you have to reason about in your build files will be assuming the top level project directory. Let this M1 Pro do its thing. All right, so wash dev is up. We built a component, started the HTTP. What's new? So the blobby example that we know, it tells you to interact with blobby. I'm gonna open another terminal here using curl commands. So essentially you go to port 8000 and you check for an existence of a file. And you can also send files here by essentially interacting with blobby as if it was like an S3 front end. The key difference here is instead of telling people to do all these curls commands and remember all the flags and so on, we added a little interface to blobby. So now blobby looks like this. The API is still the same, but we changed a few things to make it more presentable. So what can you do here is exactly the same operations that you can do using curl, but now they're a bit more visual. This page is also being served by blobby itself. So that's the other important thing here. And from here, I can upload files, and I can upload one at a time, or I can upload multiple. Get these two here. And as we are uploading these files, they are using the WASI blob store to place this data somewhere. In wash dev, all this data is in memory, meaning if I restart the wash dev session, this list clears. If we are deploying that on a Kubernetes environment, WASI blob store is backed by NATS object store. So data here would be going straight to NATS, replicated in many different ways that you can configure in NATS and so on. The other thing going on here is we have just a little activity bar here, which is local to the session, just showing us what happened. And as you do any operation on the files, you kind of get a bit of a feedback there. Nothing too fancy, but if I reload, they go away. So essentially some JavaScript code there. The other interesting thing that we added is the ability to copy links. So something that happens frequently is you upload something to Blobby and then you want to access that file. You want the URL for that file. So now we can hit the copy link and then I can likely back on curl, just do a curl for that exact file. And so this is to show Blobby in a better light and show also how you can host the UI and the API on the same WebAssembly component in a somewhat easy way. Now, in terms of the changes to Wash that I was talking about, how is Blobby being built? Let me talk about how Blobby was built before the changes here. The first thing that we do is we look at the directory and we poke the directory to identify some key files. If the directory has a cargo toml, we assume that is a Rust project, therefore we build using cargo. If we find a Go mod file, we assume that is a Go project, and then we build using Go tooling. The question is, what happens when you are in a mono repo? When you have all these things like at the top of your project? Well, wash fails. And that was bad because Rust was the preferred build method always. So as soon as you had a cargo toml anywhere in your top directory, you would have no choice other than build using Rust. So what we've done here is in this PR, and this is essentially called Project Inference. So we are looking at files that are in the project and determining how to build it. What we realized that is a bit of a game of cat and mouse. So every time there's a new flag in cargo, we would have to come back here to wash, add the flag, understand how it's going to break, force everybody to upgrade, and so on. Similarly, with JavaScript, we had to figure out if you were using yarn, PNPM, or whatever else. And all these assumptions, they were baked in code. We also realized that many of the codes that people use today, they come from templates. So what if we had essentially the build command as part of the template and also allowed developers to override the build command so they can do whatever they want? And that's the direction that we went here. So where before you could not control how Wash builds the final artifact, now you can tell Wash to use a custom build command, and you can also tell Wash where your WebAssembly file is going to be located once it's built. So we are not even forcing you to place this Wasm artifact on a specific path. You have the option of telling Wash, hey, as soon as you run make bindgen build, I'm gonna drop the Wasm on this path. And the other side here is that sometimes I'm doing a debug build and sometimes I'm doing a release build. So the way that we align that here is you can specify a different command for wash dev, likely for your debug builds. This way, when we're running wash dev, you're going to have a WebAssembly artifact with all debug symbols enabled. And the command that wash is going to be running is different than the build command. So wash build and wash dev, they have different commands. If you don't specify one command for dev, we assume that you are okay with us taking the command from build, and we just go with that. In this example here, this is a Go example. When we're doing wash dev, we don't want to be constantly running with bindgen go because it takes kind of quite a while there. So we leave bindgen only when we are really running make build. And how does this look like? If we take a look at Blobby, For Blobby, we have the command as cargo build. Pretty simple. This is essentially the same command that wash was inferring before. And we also have the component path here telling where that Wasm was built. And as we do the build command here, we can see that thing going. And we also saw the wash dev reloaded, stop wash dev for a second. And we built the artifact. Now, things get interesting when you realize that now, because you have full control of this command, you can do things like semicolon, echo user, and use environment variables that are coming from the wash environment to drive behavior down at the build level. So there you go. And this works because the same environment that we have available here on my shell is being forwarded to the build command. Therefore, any secrets that you might be setting in your CI will now make its way to your build commands. Any flags that you want to be setting, if you want to do something like wasm debug equals 1 wash build, that's going to work. And the other important thing here is variable interpolation also works here on this command. Now, together with commands, I'm just going to show here quickly a different example. This is the Go one. So for Go, we chose to use make. So we are not even adding the build commands here. And this allows us to build with wash, build with just bash if we wanted. So we have a bit more options. The other aspect of configuration will present itself when you're trying to develop services and components together. So with Wash v2, we have the concept of service, which is a long-running WebAssembly component that can be placed together with other stateless components. And we have an example for that called cron, and it's cron service and cron component. For the cron component, if we take a look at the wash config there, let me open in an editor. We have the build command. We have the component path as well. But then we have a section now on wash dev that we can say, I want wash to bring in another WebAssembly file into the workload and run that as part of the workload. So now when we do wash dev on cron component, we are developing the component and bringing in this service, which is essentially the thing that is constantly printing out here. And any changes that we do to the component, we will load the component that is under development and just reattach the service that we're talking about, the other part of the workload. And similarly, because we have cron service and cron component, if we look at cron service, it's essentially reversed. So we are here in wash dev and we are saying we are developing a service. Therefore, this is a long-running component. And we also need to bring in other components to this workload so we can develop it. And the output's going to be the same, so I'm not even gonna do that. But essentially, we are looking at wash here in terms of scope and realizing that wash should be really good at building components and bringing up a runtime for testing. The whole controlling builds and telling you how to build WebAssembly and so on used to be logic that was hard-coded in wash and pretty a source of a lot of confusions and errors. We're now essentially working more as a make file. We need to run a build command, but you tell us what the build command is. And you also tell us where the WASM artifact is going to be. And with this, we pretty much disconnect all this hard-coded logic from what people want to do. We are no longer limited by, by our own ideas here. If anybody has a better way of building a component or a faster way, they can implement that just by giving their own build command. And I'll stop here. If any questions, anything else to show here, happy to go there.
Um, I might ask you to pull up a few things, but a couple comments. I'm really excited about the direction of moving towards explicit versus implicit, and I think that that's going to really help us avoid a lot of bugs and a lot of maintenance issues going forward. One of my favorite things about what you did as part of bringing together this Blobby demo, as well as the cron service cron component, is that you're really highlighting that when you're doing a dev, wash dev run, we're assembling it as a workload. It's a workload that is conveniently assembled for what you would want to do while developing, but it's still a workload, just like what you would be deploying later on into production, into Kubernetes. So specifically on the Blobby one, it would be cool if you showed, hey, how is that backed up to a file system, right? That's what you ran here locally. I'm not sure we drilled that one home.
Yes. So good point. The Blobby example right now, what we have in Wash Dev is essentially in-memory plugins. The key value is in memory, blob store is in memory, config is in memory, you name it. Uh, we want those in-memory plugins to be backed by files. And why do we want that? And we can actually show that pretty quickly here. When we have Blobby under development, come on, Blobby, be under development. And it's up. So when Blobby is running, we come in here, upload some files. Just going to be one file now. And I go back to the code and I'm like, you know what? I need to change this thing here. And you change one thing. The component is rebuilt and you're like, I'm ready to go there and see my changes. But when you go back there, your files are gone. So this is not a good experience because imagine you having to reseed your application every time you make a change. Imagine you having to run Rails DB migrate every time you save a file. It's not ideal. So what we want to do here is move these in-memory plugins to be backed by files. So when we're talking about Blob Store, we're going to create a little directory in your home directory cache that will serve as the backing store for Blob Store. Similarly, for key value, we're also thinking of using a file system for that because it makes it fairly easy for us to map one-to-one key names in key value store to file names in a file system, where the value of each key value is the content of the file. And this way, when you want to seed Blobby, you can simply copy a bunch of files into a directory, fire up Blobby, and it's going to have everything there, regardless of how many times you restart or you change your application source code. So all to say that this is great, but has to be better in order to be useful.
Awesome. Thank you. Anybody have questions for Lucas?
I have one thing. So I guess I joined this because the architecture's changed a lot and I'm just trying to figure out what happens. So when you said that it could be backed by NATs, would it provide that backing using a host plugin or service? And if you could do both, what's the benefit of each?
Awesome. Yeah, so what we have going on here is you could bring in a plugin, you could bring in a component that is acting as your blob store interface. That's totally okay. The binding is the thinking here is that the host comes with a set of capabilities, and Blob Store is one of those capabilities. For when we're in production, the expectation is that state is not going to be in the host itself. It's not going to be on the same hardware as the compute. So for that case, when you start a new wasmCloud host, you don't have a choice. You're going to Blob Store nats. And you might be going to S3 and so on, depending on the plugin, but it's pretty much to say you don't get to pick if you're going to be an in-memory or a blob store. The plugin that you're going to use is going to be the one decided by the platform administrator when they installed the host. So you don't have to carry about the credentials to access it anymore. What you have is a configuration saying, these are the buckets I need access to. Now, the challenge with localhost is that we don't want to bring up NATs for Wash Dev, which we were doing with Wash V1. We want Wash now to be totally self-sufficient. So it's bringing up an HTTP server, it's bringing up the runtime, it's doing the file watching all inside the same process, but it doesn't have state. And we were thinking for quite a while that the in-memory state would be sufficient because that's essentially what we had back in Wash V1. But turns out that in Wash V1, most people were bringing their own providers and standing up NATs, standing up Postgres, MySQL, and so on to get the state, which means we never really addressed the problem of the in-memory state in Wash V1. So this is we re-implemented that behavior in V2, but now we realize that it's just not sufficient.
Yeah, makes sense. And then I guess just one more question. So let's say, for example, if we have a more complicated scenario where we need to have this blobby interface and be able to store files. And then let's say I also need the ability to take these files and embed them into chunks and put it into like a vector database as like a side kind of process. If I was to provide the interface that allowed me to interact with that vector database, would I have to bring that along inside the encapsulated service that like deploys with the workload? Or would I create a plugin and can you then have multiple plugins that are tightly coupled to that host?
So you would likely do a plugin in that case. And by doing a plugin, you're pretty much writing Rust that's going to have one instantiation per component. So each workload will have their own instance of that plugin.
Okay, so it's no longer one monolithic provider that all components share.
Correct.
You have this. Okay, that makes sense. Yeah,
Yeah,
thank you.
awesome. Bit of the trade-off here is essentially that before you could bring in providers via the wRPC dynamically and any name goes. With the approach that we're doing with host plugins, these are native Rust code that you put in the host. So ends up being less work, but you do need to build the host. That's the trade-off for now. There's nothing preventing anybody from implementing a wRPC, like a wRPC gateway, essentially, which operates as a workload service, receives, opens a TCP socket, gets wRPC from outside, and calls a component inside. We can still do something like that. It's just not the default way of doing things anymore. Cool. And back to you, Betty.
Gotta get to the window. Okay, hey.
I was waiting
Yeah.
for Sky High Chopper News at 11.
Yeah, I should have done that. I think my quick TLDR is that I hope to see many different components that are made available in our GHCR that folks can use for local development. And they're able to drop them in and have really nice ergonomic experience like what we just showed with Blob Store and File System. and likely also working with Nats. And that way you can kind of iterate what type of capabilities you want to provide, both developing that service side of it and also on the component side. What we have left to talk about is we've got Doc of the Week, and we actually have two Docs of the Week. And basically, Eric, if you don't mind, are you game to walk us through some of the updates you've made?
Yeah, sure thing. So we've got one landed and one in progress. I'll see if I can share my screen here. All right, so we've got an updated glossary, which adds a lot of our V2 specific terms and updates for changes to the general architecture that we've seen since V1. That is out and live right now. And right now, I'd say it's probably the best quick reference for kind of our top level concepts for V2. And in progress, in a draft PR for wasmCloud.com, we've got our new quick start. And I'd love if folks who are interested in the documentation side of things would have a look at this, maybe run through it and try it. It is mostly in place to use as it would ultimately be. This is a 3-page quick start that mostly follows the course that the V1 quick start followed, where we install Wash, choose our language and get our language tooling installed, create a new component, change the language from the component as a first initial little edit here to make it our own, and then move on to get a little meatier to add some functionality and respond with a name, and then to show us how many times we've done that with some persistent storage. And then the new piece that's a little more V2 specific is in our third step, moving on to deploy a Wasm workload in a local Kubernetes environment. So we're folding in the deployment side into the quick start to make sure that we get kind of both sides of the experience. The main piece that is missing from this right now is we need to see Wash RC6 out. And then we also want to fold in the excellent Blobby demo that Lucas showed. I think this is a great piece to show off kind of how robust what a really robust Wasm workload can look like. So we're going to add that into the last phase in our deployment in the local Kubernetes environment. So mostly just wanted to point to this as something that would love to see some feedback on, but also to let people know this is coming very soon. And if you have any questions, happy to answer them, but otherwise, back to Bailey.
Yeah. Any questions, folks? Oh, thank you, Eric, again for your excellent doc. And did you highlight that the next version's gonna really rely and show off a bit of Blobby, so you get something cute later on, because you got that PR also up.
Yep, absolutely.
Cool. And then I guess in terms of like other just wider, broader community updates, we have rolled out the next WASI P3 RC. That's now inside Wasm Time. You have to use a newer version of WIP bindgen. That version of Wasm Time is not yet released, but the idea being, and it'll be in the one that isn't coming out this month, but next month. And iteration basically continues. If folks have any questions on that, also happy to speak to it. But yeah, I feel like we've been really busy keeping our heads down and bringing a lot up, and I really appreciate a lot of the PRs that folks have been making on Wash. We've been getting a lot of really excellent, top-notch contributions. So thank you all.
There's one more thing that happened, I think was earlier this week, maybe last week. Everything's a blur now. We released a new Go component SDK, which is compatible with latest TinyGo, latest Go, and latest Wasm tools. So it's been quite a while since that refresh, and we probably were 2 versions behind on TinyGo there, but things are now back in order.
Lot going on. Lot going
Yeah.
on. Yeah.
Cool, folks. That's it for our agenda items. If there's any other topics anybody wants to bring up, anything they want to share, feel free. If not, let's get back to it and keep keep working on getting this wash out the door. All right. Well, thank you, everybody. Appreciate you joining.
Have a great
Have a
week,
good
everyone.
one.